Look up at the night sky. What do you see? Countless stars, galaxies, and possibilities. Our own galaxy, the Milky Way, has somewhere between 100 and 400 billion stars, and astronomers estimate there are at least 2 trillion galaxies in the observable universe. With numbers that vast, it feels almost inevitable that we're not alone. The math seems to suggest that intelligent life should be everywhere. So where is everybody? This simple yet profound question is the heart of the Fermi Paradox. It was famously asked by physicist Enrico Fermi during a lunch conversation back in 1950. He was talking with his colleagues about the high probability of extraterrestrial life. And then he just blurted it out. But where is everybody? And that question has echoed through science ever since. Let's break down the logic. The universe is incredibly old, about 13.8 billion years. Our solar system is relatively young, only about 4.5 billion years old. This means there have been billions of years for other civilizations to arise, develop, and even master interstellar travel. If a civilization was just 1 million years ahead of us, a mere blip in cosmic time, they should have been able to colonize the entire galaxy by now. Think about it. Even with technology just slightly more advanced than our own, a civilization could send out self-replicating probes to nearby star systems. These probes would build new probes using local materials, and then those would venture out to even more stars. This process would expand exponentially. Even at relatively slow sublight speeds, the entire Milky Way could be explored and colonized in just a few million years. So, given the billions of years of head start some planets might have had, the galaxy should be teeming with activity. We should see evidence everywhere: radio signals, massive engineering projects, or even direct visits. But we see nothing. The universe is eerily silent. This is what we call the Great Silence. No confirmed signals, no alien megastructures, no little green men showing up for a chat. It's a cosmic ghost town. And this glaring contradiction between the high probability of alien life and the complete lack of evidence for it is the Fermi Paradox. So, how do we solve this puzzle? Scientists and thinkers have proposed a huge range of possible explanations, and they fall into a few main categories. First, maybe we're just special. This is the rare Earth hypothesis. It suggests that the specific conditions that allowed life, and particularly intelligent life, to arise on Earth are incredibly unique. Maybe you need a planet of just the right size, in a stable orbit around just the right kind of star. You need a large moon to stabilize the planet's axis, a magnetic field to shield from radiation, and plate tectonics to regulate the climate and cycle nutrients. You also need the right placement in the galaxy, away from the dangerous radiation of the galactic core. When you add up all these requirements, maybe Earth is the only planet that won the cosmic lottery. It's a bit of a lonely thought, but it's a possible solution. Another category of solutions involves something called the Great Filter. This idea proposes that there's some kind of universal barrier or challenge that is extremely difficult for life to overcome. This filter could be anywhere on the evolutionary timeline. Maybe the jump from non-living matter to the first simple life is the filter. Maybe the transition from simple cells to complex, multicellular life is the one. Or, and this is the really worrying one, maybe the Great Filter is still ahead of us. What if becoming an advanced technological civilization inevitably leads to self-destruction? Perhaps through nuclear war, climate change, runaway artificial intelligence, or a genetically engineered pandemic. In this scenario, civilizations rise, discover technology, and then wipe themselves out before they ever get the chance to go interstellar. If this is true, the silence of the universe isn't a mystery. It's a warning. We might be one of the few, or the only ones, to have made it this far, but we're approaching our own potential filter. It's a sobering thought that every new technological power we unlock could also be a new way to fail the test. But let's not get too pessimistic. There are other, less terrifying possibilities. Maybe they're out there, but they're just hiding. This is the zoo hypothesis. The idea is that advanced civilizations know we're here, but they've decided not to interfere. They might be observing us like we observe animals in a nature preserve, following a strict look, but don't touch policy. They could be waiting for us to reach a certain level of technological or ethical maturity before they make contact, To them, we might be a primitive, developing species that needs to figure things out on its own. Or perhaps the universe is simply too big. The distances between stars are mind-bogglingly vast. Our fastest spacecraft would take tens of thousands of years just to reach the nearest star system, Proxima Centauri. Maybe interstellar travel is just too difficult, too expensive, or too dangerous for any civilization to bother with on a large scale. They might be broadcasting signals, but we're just not listening in the right way, or they're using a communication technology we can't even imagine yet. We've been scanning the skies for radio signals for a few decades, which is a cosmic eye blink. It's like dipping a cup into the ocean and concluding there are no whales. Another fascinating idea is that their reality is so different from ours that we would uneven recognize them as life. We're looking for carbon-based life that needs water. But what if life can exist in other forms? Maybe there are silicon-based life forms floating in the methane seas of Titan, or energy-based beings living in the plasma of a star. Perhaps they've moved beyond a physical existence entirely, uploading their consciousnesses into a digital reality. They might not be interested in exploring the physical galaxy at all. Their entire universe could exist inside a supercomputer. And then there's the simple but profound idea that we are just the first. Someone has to be. In the grand cosmic timeline, maybe we're the pioneers. Maybe billions of years from now, it will be our descendants who have spread across the galaxy, and other younger civilizations will look up at the sky and wonder, where is everybody? We could be the ancient aliens of the future. The Fermi Paradox doesn't have a single easy answer. It forces us to confront our place in the universe and the potential futures of humanity. Are we alone? Are we being watched? Or are we simply too early to the party? Each possible solution opens up a new way of seeing the cosmos and ourselves. The silence of space could be a sign of our uniqueness, a warning of future dangers, or just a reflection of our own limited understanding. For now, all we can do is keep looking, keep listening, and keep asking questions. The search for extraterrestrial intelligence isn't just about finding aliens. It's about understanding what it means to be alive and intelligent in this vast, silent universe. And the answer, whatever it may be, will change everything. Thanks for watching. If you enjoyed this journey into the cosmic unknown, don't forget to like, subscribe, and hit that notification bell for more explorations of science and the universe. See you next time.